Good evening once again. Welcome to the session 4 of Getting Oracle Database Fundamentals Right series. Today we are going to discuss about sessions and processors. Last time, if you can recall, we discussed about SGA. So SGA is basically part of the Oracle instance. So we have something called as processors also that you could see within that instance, which we didn't discuss last time. So we will touch upon those areas as well today. But before that, we will try to understand what processors are and how we can make use of them and how we can do a bit of optimization in terms of processors as well. Okay, so let me just run this session like this. Okay. About processes. So let's try to understand what exactly a process is. Now, when I say process is related to the database, right? So here we are not talking about anything else, talking about Oracle database process programming. Within the context of Oracle, what processes are. So process is, in general speaking, a process is basically a set of steps or a series of steps that we execute, right, within an OS, right? So if you talk about a process will carry out a series of steps. Right? Now, in the context of Oracle, right, these processes will run code modules. What are these code modules? There are two types of code modules that you will understand or you will identify when you have a process or when you have a database connection, basically. So whenever you want to connect to the database, you need to create what we call a database session. So when you have initiated a database session, you will find two processes. Okay. What are these two processes? I told you that a process will run code modules in terms of Oracle. Right. So what are the two processes that you will get to know? One is the application module, and the other one is the database process as well. So let's try to understand a little bit more about it. Now, when I say application, so it could be a pure play application that may invoke in order to connect to your database instance. Right, good. Now, I think you might be familiar with Apex. So you may develop an Apex application and you have that interface in order to connect to the database. So then that is an application, right? So you will spin up or you will invoke what we call an application process there. It could be, it could be an application. It could also be a DB utility. Right? Today, I will showcase a little bit of utility executions as well. Now, you might be familiar with SQL Plus. So SQL Plus is a database utility that we can run our commands against, right? So if you invoke SQL Plus, some may call it SQL Plus, when you invoke that, that's a utility that you invoke, right? So in order for you to connect to the database, you may leverage this SQL Plus tool also. Okay, so through the DB utility SQL Plus, we run our code modules also. Okay. And then we also have now, so that is basically from a client or end user perspective. Either you invoke through an application, so we call that as an application process, or it could be through a DB utility that you want to connect to the database. So that will be a DB utility based process, right? So that is from the client side or from the end user side. But in order to cater to this client process, right, you need to also have a database process invoked from the database side, where it will run the DB code. Okay, so those are the two processes or process mechanisms that we will get to see when you try to attempt or when you try to invoke a session. Right. Right. Fine. So as I was saying before, just let me take this point as well. Okay. So here you go. The first one is the client process. So client process will be through an application or through a DB utility, right? And then comes the Oracle process. So that is the second part that I was talking about, where Oracle will run the DB code, right? So that will be through the Oracle process. So when you are talking to a database through a database session, you will invoke your client process through an application or through DB utilities such as SQL Plus. And then from the database side, it has to run the DB code also in order to cater to your client process. So when it comes to client process, there are certain different types of processes that you will identify. First one is the background process. And this background process or background processors, because there are a lot of processes, and these processes will get started along with the database instance. So when you spin up or when you start your database, last time we discussed about the SGA. Apart from the SGA, there is another set of components that you will find within the instance. Those are called the background processors. So these background processors will get started along with the instance startup. So they are kind of, attached to the instance. And then we also have something called a server process or server processors that will directly, cater to the client process that I was talking about. So for example, when a client process wants to retrieve some data, let's say I want some data from my employee table, right? Server process or the corresponding server process is responsible in identifying whether the blocks that you want, where you request your the records that you're requesting, whether those blocks, the corresponding blocks, are available in the cache. If not so, or if it is already there, it is the responsibility of the server process to retrieve those blocks or retrieve those records from the blocks and hand it over to the client process. It could be a situation where you don't really find the blocks where you have the records. So server process will make a request to the database, to the disk, in order to fetch the corresponding blocks. So on behalf of the client process, server process is responsible in retrieving this data for the client process. So in other words, based on the demand or based on the request which the client process make, it is the task of the server process to get those, expectations fulfilled. Okay. And apart from that, you will also find sometimes child processes which will act internally that will do some additional tasks, right? So I don't think it's the right time to talk too much about the child processes here. But anyways, I mean, for the sake of completeness, I have added all these three here. So they are basically coming under the Oracle processors. So just to note again, when you are making a connection or database connections, there will be two processes. One is the client process that will be invoked through an application or a utility, and then come the database code that will be run through a database, Oracle process, right? So hope that part is clear. Now, there are certain challenges sometimes when you have processors invoked, right? More the number of processors that you have, more the number of resources that will be taken out from your server. Okay. Now, just before coming to that, we will also talk about how the execution of these processors will take place. Now, the execution of the processors will take place based on the behavior of the operating system. Okay. Now, if you take, for example, the Windows environment, right? And if you have noticed or if you have observed this, you will find as Oracle service, just one process running in the operating system, right? Maybe through task manager, right? Or maybe I think in the task manager, you may find it as oracle.exe or something. And then if you go to Oracle service, right? And in the service category as well. So you will find that process coming up. Okay. So, okay, now I'll show you quickly how it will look like inside a Unix or a Linux environment. Okay, I will just exit from this menu here, and I will try to share a different screen here. Just give me a second. Okay, so I'm trying to invoke. Mhm. There you go. So hope my screen is visible to you. Okay, so I should just let me just clear everything. So clear screen. Okay, so here we go. So I have okay. Let me just exit from here and then take again. So this is SQL Plus that I'm invoking, and I'm trying to log into the database as the super user. So this is that utility that I was talking about. So this basically creates a client process, right? And now what I want to show you was before that, okay? PSCF grep2 aura underscore. So you find that quite a lot of processors that are getting spin, right? So if you are wondering what these things are, so these are basically, I mean, most of them are actually the background processes that you run that you find within the instance. So this prod 221 is the name of the instance of the database. And so these are all processes attached to that instance, right? So you can see quite a lot, right? They all have their own process IDs, right? And so this is not really the behavior that you find in a Windows environment. So in Windows environment, you find one Oracle process and that's it. So all these background processes that you find are like um, going inside or will be there inside that process of a single Windows is it single Windows process. Okay. Now, so what does that mean? So what that means is that in Windows, you have a single process, but you have multiples of threads that is attached to the process, right? So although you see it as a single process, behind the scene or under the covers, you find quite a lot of threads that are getting executed. So all these threads are attached or is dependent on the parent process. So rather than seeing many number of processes, you find a single process, but under that, so sometimes you might be able to see a process tree in a Unix environment, or maybe I'm not too sure whether it is possible to do in Windows. But however, when you run, you can see the process tree, and then you can see all the dependent, threads that are part of the same process. Okay, so this is one of the differences that you find in Windows and Linux. I mean, Windows versus Linux and Unix environment. Uh, so yeah, so this is just I wanted to share with you. Now the challenge is this. Okay, the challenge is that you can see quite a lot of processors getting invoked. Now the number of processors increase, or the moment you have quite a lot of processors increase, these resources will consume resources in the database or in the host where you have your database running. So if you have, if you can remember, when a database connection is established, right, in a general scenario, you have your client process that might probably be invoked from a client tool. The other thing is that the database code that will be running using Oracle process, right, such as a server process, will get spawned in the database itself, right? So per connection, you may find the processes getting increased, right? But only thing that you have to always remember is that since a process can have multiple threads, right? There could be situations where you don't really see the increment of the processes, but you may see the increase in the number of threads rather than the processes. Okay? But in a generic context, if you find more processes getting spawned, then there could be sometimes a challenge to the operating system as well, because you may run out of processes. So if it runs out of processes, you may not be able to work with that environment. Okay. So if you really want, we can have these processors. Okay. So mind you, there are some Unix or Linux based processors of Oracle that might still be using threaded execution, meaning one process, multiple threads attached, right? But you can't see it here, but it is possible, but not everything. Now, you can see anyways quite a lot of processors running here, right? So this is significant. Okay. So if you really want to try and see how we can merge them, or how we can enable threaded execution, you can also give a kind of a Windows feeling to this Linux environment as well. Okay. So let me show you how we can do that quickly. So when I connect to my database, show parameter, sorry, show parameter, uh, we do execution. You can see here, in my case, the threaded execution parameter is currently set to false, right? So I have not enabled the threaded execution here in this environment, right? So the moment you enable threaded execution, Oracle will try to combine or will try to attach multiple threads to a single process rather than spawning many processes, right? So that's the whole understanding that we have. Okay, right. So when you do this, you can see that threaded execution is set to false, right? And also I will show you something else. Show parameter in broker. Okay, so this is another parameter called use dedicated broker. So I will explain you about dedicated broker a little later on. But for now, just keep in mind that this parameter is set to false as well. Okay, so I have not enabled threaded execution. Hence, this is in this environment. So therefore, it is false. And my use dedicated broker is also currently set to false. Okay, so what I do is I want my environment to have less number of processes, so that how I can do that is basically by enabling threaded execution. So the moment I enable threaded execution, I should be able to see lesser number of processes. Right now here you can see quite a lot of processes running. I want to see a reduction of these processes. So that means those there are threads instead of processes getting attached to a single or fewer number of processes. Right. Hope that part is clear. So let me try to enable this by using alter system. Set threaded execution is set to true. Now this parameters is a static parameter. I think in one of our previous lessons, we discussed about static and dynamic parameters. So this is static, hence we need to restart the database. So let me just do scope equals sp file to make it applied onto the parameter file, and then we do a restart. So I use srvctl command to stop my database, and my database name is prod21. Okay, so let's just wait until that finishes. So I use this srvctl command because it's a the srvctl stands for server control. Okay, so I have stopped my database. I'm going to restart my database. So let's see what happens then. So why am I doing this? I want this to make sure that I reduce the number of processes, right? I reduce the number of processes so that I can preserve or I can save some resources within my environment. Otherwise, sometimes, you never know when the processes get exceeded. Okay, so that is the whole purpose. There are some other side effects as well when you enable multi-threading, threaded execution. So let's I'll demonstrate that as well. Now the database is coming up. So hopefully once that is started, I should be able to show you the effects of that as well. Okay. So, so as usual, if you have any questions, any doubts or concerns, queries, make sure that you throw it out then and there. So we'll be able to explain it within this session itself. Okay. So still the database is coming up.
Excuse me, Mr. Gayan.
Yeah.
I have one question. This process does it have any relationship with the process parameter? Like is that the one that controls the number of processes that it can have, like the process limit parameter?
That's right. So these are all part of that as well. So because now the moment you have sometimes you will get to experience that the processes have exceeded. Now, see for example, if a connection gives you or generates an additional process, right? Like the Oracle process that I was talking about, right? So if you increase the number of user sessions, what happens is that indirectly it will increase the number of processes also, right? So when you say process parameter, when you said that process parameter, it applies to these database connections related connectivity related processes as well as these background processes also. So it is all inclusive. So the moment we try to reduce the number of processes, then the chance of you getting this error of out of processes can be eliminated or can be reduced, minimized.
Okay.
Right.
So in that sense, like enabling thread execution will reduce the number of processes, right?
Exactly. I'll show you now, Kavindu. Now you can see.
Thank you.
Yeah, no worries. So what I'm going to show you now is the number of Oracle processors, right? So here earlier we ran this command ps minus ef grep to ora to figure out the Oracle related processes that are running here. Okay. So same thing once we have changed the threaded execution. Oh, sorry. Es minus ef to grep to ora underscore. Okay, now we will see the number of processes had got drastically reduced. Right. So this doesn't mean that these processes are no more there. They're all there, but they now come under one of these processes. I mean, could be one or two, but there could be many threads that gets executed within these processes. Right. So that's the understanding that you have to have. Earlier, we had quite a lot of processes. Now they have got reduced to a limited number of processes while making sure those other processes that we saw earlier now have become threads instead of processes. Okay. So this way, we should be able to reduce the number of processes that are being occupied. And of course, that will give us more buffer, more space to accommodate additional processes. Okay. Right. Now, let me show you one additional thing. Now I'm trying to connect as sysdba, just the same way that I logged into the database previously. Now this time when I type SQL plus as sysdba, then I get an error saying invalid username password. Okay, now this is a kind of an effect that you find once you enable threaded execution, meaning you will not be able to use your OS credentials to log into your database. Now here what we are trying to do is we are not passing any password here. We're just doing / and login as sysdba simply because we are the owner of the Oracle software. So I have logged into the operating system as the Oracle software owner, right? So that way I got that privilege of bypassing any database related password. But now they won't allow me to do that, right? So how can I connect? If I want to use the same sysdba connection, I need to use SQL pass sys at prod 21. So that's my connect string as sysdba. And I need to give the right password in order to connect. Okay, so the moment you have enabled threaded execution, you will not be able to do slash as sysdba. So that's a restriction that will be imposed. In addition to that, let's check our parameters. Parameter thread. So if you check threaded execution, it is true as we saw. This is the change that we did, and also the broker. You can see the use dedicated broker. Earlier we found it false, but now it has become true as well. So although we have not changed this explicitly, the moment you change the threaded execution, the use dedicated broker parameter will also turn true. Similarly, if you make this false, this will become false also, right? So what I'm going to do now, I'm going to revert my change. I will explain this while the database gets restarted to save time, right? So I will quickly do I will change my setting to alter system, set threaded execution to false, scope equals SP file. Then I do a restart quickly. Okay, so until such time, I will explain you briefly about this dedicated broker. So when threaded execution is enabled, the dedicated broker becomes available as well. So what happens is that whenever you want to connect to a database, there is a requirement of spawning what we call a server process. Right now, here I'm explaining at a very high level because later on I will give you an alternative way as well to connect. But in a generic level, right, we use what we call a server process. So server process is kind of responsible in doing the catering to the user process, right? So that's what we learned earlier at the beginning of this in this presentation. So when you are doing this, okay, so when you are doing this now, when this becomes true, dedicated broker, listener actually creates another server process in order to manage these threaded executions, right? So when a new session is going to be spawned, that dedicated session or dedicated server process is responsible in generating the server processes on behalf of the listener. Right? So that is how it happens. Why we want them, we'll discuss it. Probably not now. It is going to be a little too much for you all. But since these are all related, I'm going to explain it. So just keep in mind, we can have this use dedicated broker parameter will become true, so that the listener will have a dedicated server process in order to generate the server processes on behalf of the listener for the user processes when we request sessions. But that happens only when we change the threaded execution. Okay, right. So this got stopped. Let me just start it as well. Okay.
Sorry, Mr. Gayan, I have some question. Can I
Yeah.
ask it?
Yeah. Sure.
So if in our database, if how the processes count is near to maximum, have
Hmm?
there any alternative to reduce that process count behalf of the increase the process count? Just increase
Oh,
just increasing the process parameter
hmm.
and any method to reduce the number of process or optimize resources usage.
Right. So as long as, I mean, okay, so you can probably view, sorry, this is getting started. So we have this view called $V resource limit. So through $V resource limit, you should be able to kind of monitor the resource usage. So one of them is the processors that you just mentioned. So processors is more into now, of course, processors parameter in general is not a performance, what you call performance hitting parameter. There are two types of parameters, performance-based parameters, and we also have something called as limiting parameters, right? So processors parameter basically is kind of coming under the section called limiting parameters. So if I want to limit the number of processors, I set a process limit, right? True enough, indirectly, it might affect the performance also, but using these parameters, the priority of this usage of this parameter is to limit the number of processors that someone can invoke, right? So the problem that you had was, okay, so we have a parameter set or processors parameter set, but now it is hitting the maximum. What we can do? So as I mentioned you earlier, whenever a database connection gets established in a normal routine, right, there will be a server process allocated that will be spawned by the listener, right? More the number of users that you log in, more the number of server processes that will get generated. Okay, right. So couple of things here. One is you can see whether it is possible for us to limit the number of user connections coming onto the database. How can you do that? So you have something called as profiles. So through profiles, maybe you can limit the number of sessions a particular user can open. So we will limit that. So that is one option that you have from a resource controlling perspective. The other thing is, as I just showed you here, we should be able to enable a threaded execution. So the moment you enable threaded execution, then also you may not really change the process parameter, but the process usage will be less. Okay, right. So that is number two. Number three is in order to reduce the number of processors, you can also opt for, now, I told you the generic behavior is per session, a server process will be invoked, right? So what if we can share the dedicated server process that you have for a particular session? Meaning you can have a limited number of server processes generated by the listener. So whenever a user connection comes in, that user session will consume whoever the available server process. So that means we have a fixed number of server processes allocated rather than giving one dedicated server process per user connection. So that's another way that we can think of, right? So therefore, we probably have three ways. One, of course, as we just did here, you enable threaded execution. And number two, you can control the number of sessions that can be opened by a particular session through profiles. Number three, rather than giving dedicated server processors for each connection, we can have what we call a shared connection or shared server connection. So which means you have a limited number of server processors. So that will not vary based on the number of connections or sessions that you want to open. Say example, maybe you have determined only 10 server processors, right? So if you have 100 users connecting or 200 or 500 users connecting, still that number of server processors will not change. So it will be just limited to 10. So that way also we should be able to control this, right? But the challenge here is that in case if you are to change the processor's parameter, unfortunately, it's a static parameter which requires a restart, right? Sometimes I think people will have challenges even to log into the database, right? Because of process exhausting. So in such cases, what we do is we kind of kill one or two sessions to release these processes. And then we try to log in and do the necessary other activities. Okay, so hope I have given you a proper answer to that.
Yeah, thank you.
Right, sure. So now I have started my database. let's try to log in with the /assist DBA so it works, because now the threaded application is no more there, right? So sorry, threaded execution is no more there. Okay, so let me just quickly go back to my presentation as well once again. Okay, so let me. Fine. So you can see what we have done so far. We figure out what is the impact of the threaded execution parameter. And in addition to that, we also found the broker parameter getting changed automatically as well. Not the database broker, that is the threaded execution broker parameter, but yeah. So there is another parameter. This is another parameter that you are finding here, dedicated through broker. So dedicated through broker is a parameter that you don't set in the database level, right? So that's a parameter that you set in your listener.aura file. So if you are aware of listener, we will talk about a little bit on listener as well later on today. But just keep in mind, you have to have this is defined for the listener also. So the moment you do this, what happens is that the listener will be capable of delivering or creating threads instead of processors in order to serve user requests. So that way also you will be able to drastically reduce the number of processors in your database. Okay. Right. So make sure that when you are setting this parameter to enable dedicated through broker underscore listener, means you need to figure out the name of your listener. And this entry will not go into your database, but as an entry in the listener.aura file, which is the configuration file of our listener. So let's talk about listener as we move on. Okay, so this is the whole picture. You can see that we have the whole instance that comprises of the SGA, which we discussed last time. And we also have this section here. Okay, before that, we also have these background processes. We found some background processes running in our Linux environment. We queried using PSEF, and we found quite a lot of background processes running. So these are some of the important background processes that will do certain activities. And these are also consuming processes, right? So what we did was we reduced the number of processes, we made them into threads. And that's how we actually reduce the number of processes in terms of background processes, right? So then talking about the server process. Now I told you about the server process, which is the Oracle process that will run the database code. And when a client process through a utility or through an application, when you invoke it, right, all the activities on behalf of the client process will be done by the server process, right? So client process will also, client process will also have his own private space for his private executions. So all these will be managed within a memory area called PGA. And this PGA is bound or is attached to the server process. So when I say attached, so this PGA is actually a private space for client process. Since this server process is dedicated for the client process, then this server process will also use this space in order to keep client private information. It could be about session information. It could be some SQL, session. Let's say now when user opens up cursors, the state of cursors. So likewise, all this information will be kept in a private area, and that will be updated by the server process. Now the thing is that server process is also capable of compiling your code. In other words, you call it the parsing stage. So it parses the code that you type. So all these will be done by the server process, and fetching data from the disk or from the buffers if needed. All these things will be done by the server process. Okay, so this is that part which is staying outside the SGA. But then this if you combine the shared the SGA area and the database background processes that will basically create the instance for us, right? So here down, you can see the physical files that are there and from which we do IO operations. Okay, fine. So we go, and I'm not going to discuss again about the SGA because we did that discussion last time. Now, so there's a question on how we can reduce the number of processes. And so I told you about this scenario of dedicated server versus shared server as well that time. Okay. Now, in a dedicated server connection, what happens is that whenever a client process or a new user wants to connect to the database and fetch data, then for each of these client process, in order to support that client process, there will be a separate server process that will be spawned by the listener, right? So although we did not discuss about the listener as yet, always remember when the client wants to make a database connection established, first, the client process, it could be that utility like SQL Plus, or it could be an application, first needs to reach to the listener. So listener might be residing on the database host itself, or the database might be in a different host where listener is not running. So listener might be running on one machine. The database might be running on another machine as well. But in a generic situation, database and the listener will be running on the same host. Okay, so when user wants to make a request, it goes and talks to the listener, and listener will do some validations because the user has to be a proper user. The user should be able to, or user might be requesting, or user should be requesting the right service to connect. Right? All this information has to be validated. So once they are correct, listener is responsible now in spawning a new dedicated server process. So that dedicated server process will live until your user process or user session gets killed or gets terminated. Right? Now, if for some reason, if that user has opened his session, but he has not disconnected, but he has gone out for lunch, right? Still, the dedicated server process will remain, and it will remain in idle, right? So there could be, something, some disadvantages over that as well. So this is how the generic behavior is when it comes to dedicated server, or when it comes to database connections, because the dedicated server connection is the default behavior. But at the same time, if you want to reduce the number of processes, right, we can also opt for this method called shared server connections. In shared server connections, clients will not talk or will not have a dedicated server process allocated. When a request comes to connect, of course, to the listener as usual, listener will now identify an idling process called dispatcher. Right now, this time it is not going to be a server process, but there will be some dispatchers which are running already, which are pre-spawned. So the listener will identify one of the least loaded dispatchers, and the user request, or sorry, the client will be connecting or will make the get the service from dispatcher. So once the connection is established, right, the dispatcher will take the request of the customer, of the end user, right? So if there is a query to be compiled and executed, so that request dispatcher will place into what we call a request queue that is inside your SGA. Okay, so there will be a separate area under the shared location called shared pool within SGA, and all these requests that are coming in from these end users will be placed on a queue. So from the queue, now this has to be executed, right? So there's a request coming from the users. So the request will be taken up by one of the idling server processes. So that is why I said listener process will initially pre-spawn a certain number of server processes rather than giving the users individual server processes. So then maybe one of the idle server processes will take that request from the request queue and will do the processing, and server process will hand it over to a response queue which is pertaining to a given dispatcher. Because if dispatcher A is the one who had kept the request, server process will process and get the result which is required by the end user, and that result will be kept in the response queue of A. Right? So from A, dispatcher A can take that response and hand it back to the end user. Okay, so in a shared server situation, the configuration is slightly different. You may have to define your dispatchers, and you need to define a pre-spawned number of server processes. And this is different from what you find in a dedicated server. In dedicated server, there will be no pre-spawned server processes, but whenever a request comes, or request in the sense new connection comes, listener is responsible in creating a new process, new server process for the client process. But here, at the beginning itself, there will be a limited number of server processes spawned. Okay, so that is how the shared server configuration works. So the term shared server meaning you are not really utilizing, or you are not creating dedicated servers for each of these client connections, but there will be a certain number of predefined server processes that will be catering to the user request based on the availability. Okay. Another important thing is that a particular task of a user can be executed by multiple shared servers, multiple shared server processes also. Example, maybe the end user wants to run a query that fetches 2 records from employee table, another 5 records from, let's say, another table, right? So that could be catered by a single server process. It could also be catered by multiple server processes also. That's a difference that you find in this kind of situation. But however, it will be to the same response queue. Ultimately, the result will come, right? Because you need to have the right dispatcher to deliver the content to the right end user. Okay. So that is how the shared server, dedicated and the shared server configuration works. All right. So we have spent quite a lot of time here. Anyway, so let me just run through a little, some, important background processes. So PMON, these are all background processes that will be spawned when the instance gets started up, right? So they have their own tasks to do, but at a very high level, process monitor or the PMON is responsible in identifying dead connections, right? So if there are abnormal terminations of maybe a user, right? User is no more there, but the dedicated server process or maybe the server process is still holding logs and other resources of this end user. So it has to be cleared, right? So the task of the PMON is to time spin up automatically and figure out whether such dead connections are there. If so, to clear up those resources. Systems monitor is responsible primarily to do instance recovery. When something happens to the database and your database gets crashed, you do a startup next time. Then the database will undergo what we call an instance recovery, because some of the content might have got committed but not written appropriate to the data files or database. So you need to recall them and update them appropriately. So initiating this instance recovery is done by SMON. And then we also have RECO, is basically for distributed transactions. If there are transactions happening from multiple data sources and you need to do the coordination part, if there's a failure, you need to detect that. So all these things are basically managed through RECO background process. MON, when you run your diagnostics, right, Oracle basically creates what we call automatic workload repositories, snapshots, where it creates snapshots of your current database health, right? And those will be flushed onto a table space called sysocs. So that will be basically done by the memory monitor. Then memory management background process is also here, and that is basically is responsible in capturing statistics such as active session history and so on. And then we also have the database writer process. So N means you can have many processes, not just one. From 0 to 9, altogether 10 background DBW processes can be invoked, and he is responsible in writing all this changed data. If you can recall, I was talking about dirty buffers rather last time. So dirty buffers, flushing them to the disk to make the database consistent is basically a responsibility of the database writer. Then checkpoint is the process that will ensure synchronization of the database, that is flushing to initiate the flushing of these dirty buffers to the data files will be initiated through checkpoint. So once a checkpoint gets invoked, database writer will be called in order to write these changes to the database. Log writer is responsible in writing the changes that are happening at the database front. So if you are changing a database block, maybe you are updating your employee record from A to B, then somebody has to keep a track of what changes you are doing, and those changes will be tracked separately and will be going into a redo log buffer. And so I think we discussed this one last time in the session. And from the buffer, log writer is responsible in writing them back to the redo log files, right? Archiver process is basically responsible in taking backups of the redo log files in the event if you want to do incomplete recoveries, or if you want to do point in time recoveries. And then we also have the RVWR. So that's basically the recovery writer, which is responsible in generating flashback logs. So in the event if you have, if you want, let's say the database to be rewound to a certain point in time rather than relying on a backup and doing a recovery, you can enable flashback database. So if you enable flashback database, again, you need somebody to track the changes that are occurring at the database front, and that will be done by the recovery writer. Okay, so these are some of the common background processes that we will see. Why I took this one is because that will make the session complete, because we need to talk about the background processes also, since it's part of the instance which we discussed last time. So we discussed about SGA, but we did not discuss about this background process there. So Oracle Net Listener, or we call it the TNS listener, Transparent Network Substrate. That's the term TNS stands for. So Net Listener is basically configured to listen to a certain protocol address. So I have given an example here. You can see the address talks about protocol, which is TCP here, and hostname, probably the database hostname, and then port number, right? So listener will be having these address, right? Will be having one address or multiple addresses also. So for example, you may have same protocol, but it might be using a different port number as well. Okay. So when you want to connect to the database, this information is to be known by the end user or the client. Client should know what is the host to be reached in order to reach up to this listener, what is the protocol that the listener can listen to, and also the listening port number. So here 1521 is the default port number for your database. Generally, I mean, it's a known number. So not for security purposes, we do change this number. We don't keep as is, but this is the default port number. And then you don't need to configure anything as such, because there will be a default listener that will be spawned in a normal environment. But at the same time, if you are using Oracle cluster, or we call it Oracle grid setup, be it a cluster or even in standalone setups, we can invoke grid. So when you run the grid installation or configuration, there will be a default listener that will be spinned up, and that default listener would be listener. That's the name of the listener, right? So, but you can also create your own custom listeners as well. It's not a problem. Through different services like NetCA, you can create a new listener and so on, right? So when the listener is created and when you start your database, the database services will get automatically registered with the database. Now here I just have given you a small snapshot of it. You can see service PDB1, service prod 21, right? So likewise, there are services. So this is what we call dynamic registration, meaning when a database gets started, when the listener is also running, right? We have a parameter also if you are running multiple listeners, and that parameter is called local listener. We can set the local listener parameter to the listener that you want for that particular database, and the database will automatically get registered when once it gets started. So when the database gets shut down, it will be deregistered, right? So what do you mean by a service? Now, when you're connecting to your database, you may have a database name, right? But at the same time, you may have multiple database service names also. Service names are generally created through an interface called SRUCTL or DBMS underscore service package. You can create services. Let me give you one example in case if you are unable to figure out what a service is. So service is basically like, say I have my database called prod, right? But I have two applications connecting to this. One is payroll, one is HR. So I can create one service called HR, one service called prod. So when users want to connect to prod, what do you call, to my same database, but they are connecting to the application HR, I will give them what we call a connect string that refers to the service name HR, right? So for those who want to connect to a payroll, I will give a connect string for them to connect to the service called payroll. So what are the advantages? Of course, we can differentiate. So at any given time, I can shut down my service called payroll. So the database is not shut down. It's most likely the payroll users will not be able to connect though. Similarly, I can figure out the performance levels, how much of resources each of these services are taking and how I can optimize it. Right. So these are generic advantages of using services. At the same time, if you're using a clustered environment, you can give advanced settings or advanced configurations also for these services. For example, how you can do load balancing, how you can do automatic failover, right? And what type of failover mechanisms that you need to incorporate. So there are quite a lot of attributes that you can set on a particular service at a cluster level, right? So there are many advantages of that. So who's responsible in basically doing this dynamic registration? There's another background process called LREG. So listener registration process is responsible in starting these or getting these services registered when the databases are getting started. Okay. So continuing with the net listener, I told you about the dynamic registration. So dynamic registration happens with this parameter setting called listener, sorry, local listener. I told you that, right? So in our database, you can set the local listener parameter corresponding to the listener that you want to have, because in your environment, you may have one listener running, or it could be multiple listeners also. So you want to be very specific in getting registered with a single listener or then you can have that value set here. So this value represents an alias, right? So it basically, if you check your connect, your connectivity, this is the connect string that I'm using. Oh, sorry, I think I have not given the right one here. There's this value called listener prod 221, right? So my corresponding entry will be like listener underscore prod 21. This is not the right one, but it will, if you check your your name resolution happens through TNS names file, if you are aware of it. So the TNS names file will have an entry for listener underscore prod 21. So it will say that, okay, it is trying to connect to this host and listening on this port number. So I think this entry that you're seeing is correct, referring to the correct listener. But then this connect, alias is wrong. It should be listener underscore prod 21, right? And sometimes, as I was saying before, you may have your listener running in one machine, but your database instance might be running on a different machine. This is more applicable in a clustered environment where you want to connect to a remote instance rather than connecting to your own instance, right? So for that, we use what we call a remote listener, another parameter that will refer to, here I have not given the value. So that will also resolve to an entry like this, but this host might not be the local host. It could be a different host than the local host. And port number, of course, it could be the default port number or something else, which is, where other listener is listening on. Okay, so you have local listener and you also have remote listener pointing to a remote listener. And I told you about the shared server connections. So shared server connections, you need to have your dispatchers, right? So you can see here, you can create the number of dispatchers you want. Now, where would the dispatchers be helpful? In a shared server connection, I told you the workload, or when a user is requesting work, right? So user's request will be obtained by the dispatcher. So dispatcher is responsible in having that request placed on the queue, right? That is a request queue. And once the operation or the request has been processed by the server process, the corresponding response queue from which the dispatcher will take data or take output and will be returned back to the end user. So until the user performs another task, right, your dispatcher will be there for the client process. Okay, so in order to set the number of dispatchers, you can specify the protocol that you're using and the listener that you want to connect with. Right? So here also you can specify the address of the listener. So we saw the address of the listener, something similar to this, right? I think here also you have, okay. So this address can be mentioned here as well, or it could be a connect string that refers to the listener's address. Okay, so then about connecting to the database. So when you are connecting to the database, you use something called as connect string, right? Now connect string is something similar to this that will be reflected in tns names.aura file in your client machine, right? Or so if your client might be your database host itself, so it could be there as well. So, however, if you browse through this, you find that you will have an alias here. So any name you can give here, but something meaningful probably. And then you can see what is that address that you're looking for in connecting to the listener, right? So this is that listener's address that you have to mention. So in this case, it is searching in this host for the listeners listening on 1521. Okay. And you can also see that you have something called a server equals dedicated. So I told you about the two different mechanisms in which the server processors can, support user processes. One is dedicated, the other one is shared. So if it is dedicated, so here we are explicitly asking for a dedicated connection so that, we are not helped, or this connection will not be helped by dispatchers. Right? So if you are using dispatcher, then if you are explicitly asking for it, then you can say server equals shared. Okay. One important thing to mention, if it is if it is shared, right, there are some limitations when you have created your session using a shared connection. For example, now, as you can see from the logics of it, whenever you make the request will first go to request queue. Right? Then you need to have a available or idling server process to take up that request. So if you take critical operations, let's say you want to invoke a backup or you want to immediately shut down the database, then if you keep your request in a request queue, waiting for it to process, then that will not make sense. Right? So there are certain commands that cannot be executed through a shared server connection, such as your shutdown operations or backup operations. So those major operations you cannot invoke through a shared server connection. You need to have a dedicated server connection. And then this service name. I took some examples, the payroll, the HR I told you. So you can just mention the service name here. So then if this service name is registered already within the listener, then the listener can pass that request to the appropriate handler. So then the database connection can be established. Okay, so this is where the service name will come into play. And I told you, you might be connecting to the same database, but because of the service name differences, users might feel that they are going into their own database. Right? Okay, so that brings us to the end of the session. So we're about 5 minutes past the time, but I think I managed to cover what I wanted to cover. So there were some questions also being asked, which is good. And we always encourage you to have interactions. Only thing is that we have we have 1 hour to complete our session. So I don't want it to be very big as well. Because sometimes, or for some users or some of you, these might be something new. Yeah, so that's it. So any questions that you all have?
I'll
Right.
stop the recording for now. So if anyone have any questions, they can ask.